symmetric, bell-shaped. It's the normal curve. It's so important, it gets a capital N. But this is more than just the normal curve. It's also an ingredient. We're making cookies in this video. So it's second semester of AP Statistics and your teacher keeps saying area under the curve. And you know you learned it at some point, but it comes up so often now.
At this point, I'm too afraid to ask.
Don't worry, I've got you covered. So the example today is all about cookies. If you're hungry, maybe get a snack before you watch this video. A normal batch of chocolate chip cookies usually takes like 10 to 12 minutes to bake, and the cookies I'm making for this video come from sallysbakingaddiction.com. They're her like soft chocolate chip cookie recipe. If I take every batch of these cookies that I've ever made and I put them all on a distribution showing the amount of time I had to bake each batch, most of the time I have to bake them between 10 and 12 minutes. But there are occasionally moments where I have to bake them much longer. Maybe the oven was really slow to warm up, and sometimes I bake them much shorter. Maybe I've been baking all day and the oven is really hot and they just don't need as much time. But mostly it's going to take between 10 and 12 minutes to bake. As you can see, this distribution looks pretty normal. It's symmetric, it's bell-shaped, most of the data is in the middle, very few data points are out on the ends. So this distribution is showing you specifically these 53 times that I've baked the cookies, how long each batch took. But we're going to turn this specific distribution of 53 bake times into a model that could model all the bake times. Like if I made this recipe hundreds and hundreds and thousands and millions of times, which we'll see how good they taste when they come out. Maybe we'll do it. This describes all those millions of times. The mean bake time of this model is 11.6. So most of the time it takes 11.6 minutes to bake. And we're talking about the population of all bake times, so we're going to call this mu. The standard deviation is 1.1. So most of the batches take between 10.5 and 12.7 minutes to bake. Now this curve shows every possible bake time there is. 100% of the batches of cookies I could make are under this curve. So if you get a question like, what percent of batches take more than 12 minutes to bake, they're asking you to find the area under the curve that meets this description, more than 12 minutes. So 12 minutes, that's like about half a standard deviation above the mean, so maybe like here-ish. More than 12 minutes would be this tail of the graph. So once again, under the entire curve is all the possible batches of cookies I could make. There's a batch right here that takes 9 minutes. There's a batch right here that takes exactly 11.6 minutes. There's a batch over here that somehow takes 15 minutes. So to find the percent of batches that take more than 12 minutes, I just have to find 12 minutes along the axis here, and more than means to the right. This area under the curve represents all of the times that I had to bake cookies longer than 12 minutes. Okay, now we're going to use a calculator for this. I'm going to write it out first, and then I'll show you where to find the buttons. So on your calculator, you're going to use something called normcdf. Normcdf is just the function we use to find the area under a curve. The first two things that you have to type into the calculator are lower and upper. This is basically telling your calculator the lower limit of where you want it to start measuring to the upper limit. The left side or lower side of this area that I want to find is 12. So what you want to say for upper is something that's obviously too big, like way too big. That way we get the entire right side of the distribution included. So you could say like 20 or 25. It seems like that's probably like well beyond where the curve ends. But I'm just going to put in 10,000. If a batch of cookies takes more than 10,000 minutes, you're doing something wrong. The next two things that the calculator needs to know are the mean and the standard deviation. So we're going to type in 11.6 and we're going to type in 1.1. Now, if you are taking the AP exam, it's really important that you include the words lower, upper, mu, and standard deviation, or even just the letters L and U should be fine. The reason you want to do that is you're trying to prove to whoever's grading your work that you actually know what you're doing. So if you're using calculator speak, just make sure you label what each thing is. It's just a little added proof that you do know what you're doing. All right, so I'm going to show you on the TI-84. This is the Plus C Silver Edition. Fancy. You're going to click second and then the vars key, and you'll see right above it, it says DISTR, that's distribution. and then you're going to pick normcdf. Do not pick normPDF.
What about that shadowy place?
You must never go there, Simba.
All right, hit enter. Now, if you have a fancy TI Plus, lucky you, you've got this menu. So you just get to type things in. If you have an 83, you can still do this. You won't get the fancy menu. What you're going to type in is 12, 10,000, 11.6, 1.1. So the downside of having an older calculator is you have to memorize the order of those things. There's nothing wrong with old calculators. I've been using the same 83 since 8th grade. All right, hit enter. Okay, it's going to give you a proportion. The calculator uses, instead of percents, it does proportions. So 0.358. As a percent, that would be 35.8%. So 35.8% of batches take more than 12 minutes to bake. The great thing about these questions is you can double check that your answer makes sense. If you drew your drawing really nicely, you can see that your answer should be less than 50%, because this is above the mean. And we were like half a standard deviation above, so it makes sense that it's almost 50. And now we know that only 35.8% of batches should take more than 12 minutes. A question like this is phrased differently. It says, what's the probability that batches take between 10 and 12 minutes to bake? But it's no different than asking what percent of the batches take between 10 and 12 minutes to make. The area of the curve is 1. It's all the possible outcomes. That's the sample space. All the possible things that could happen when you bake your cookies. So the probability is the same thing as asking what percent. So for this problem, what's the probability that the batches take between 10 and 12 minutes? Exact same thing. You go to normcdf, but for lower and upper, you're going to put 10 and 12. So second vars, go down to normcdf, and if you're lucky, everything's still there. You just have to type in 10 and 12. Everything else is good. 56.9%. So there's a 56.9% chance that the batch takes between 10 and 12 minutes to bake. This question's worded a little differently. How quickly do the fastest 10% of batches take to bake? So they give you the percent or the area under the curve, and you have to work backwards to figure out the number of minutes. So fastest 10%, that would be at the bottom, right? Yeah, faster would be less minutes. Fewer minutes? Less minutes. Fewer or less? I don't know. So this area right here is 10%. Now, if you know the area and you're working backwards to find this minute right here, instead of normcdf, you're going to do inverse norm. Now, instead of lower and upper, they're going to ask you for area, and you're going to put in 0.10, and then mean and standard deviation, just like before. Now, if you have a TI-83, it is always going to assume that you're talking about area to the left. So for this example, we would put in 0.1. If it were an example where we were looking for the top 10% or the longest 10% of bakes, then we would have to put in 0.9 as our area, because the TI-83 is always thinking about area to the left. Now, depending on the model of calculator you have, it might ask you area to the left or to the right. So on my model, it doesn't ask. Yours might say at the top, like left, center, or right, I think, is how it phrases it. But on my calculator, it doesn't give me an option. So I just have to assume it's talking about area to the left. So we're going to click enter, 10.19. And I think that makes sense. That is pretty far below the mean. Definitely below 1 standard deviation. So that bottom 10% is pretty small. Makes sense that it would be more than a standard deviation below. All right, so this was the basics of normcdf and inverse norm. I have more videos that go into this more in depth. So if you'd like to see those, is it this side or this side? I'll put it here, somewhere. But while I'm baking cookies, I think what we should do is bake a second kind of cookie that takes a much longer time to bake. A chocolate chip cookie, but make it giant. And we'll see what happens when we compare two different curves. So that'll be in the next video. If you have any questions that you're too afraid to ask, please leave a comment. I'd love to make more of these videos for you. And hit that subscribe button so you don't miss any of my AP review content. Holy moly. Hey, I told you to get a snack before this video, okay? It is not my fault. I'll put the recipe in the description. I'm gonna go grab another one.